Today's video is on solubility equilibria. So let's jump straight into it. So substances we often describe as being soluble or insoluble, but this is an oversimplification. No substance is actually completely insoluble. There is always a quantity in solution, and when we say in solution, we mean dissolved. And it doesn't matter even how tiny this quantity in solution is, there is always a quantity that's going to be in solution. So no substance is completely insoluble. So substances dissolving is an example of a chemical equilibrium. And the chemical equilibriums we're going to be looking at are of sparingly soluble compounds. So this means compounds with a lower solubility, so low or lower solubility. So an example of this is dissolving calcium carbonate, and we can see that this is a equilibrium. So we have our calcium carbonate solid, and then we dissolve it into our calcium ions and our carbonate ions, which are both aqueous because they're dissolved in solution. And this is a chemical equilibrium. So an equilibrium constant can tell us how far to the right or to the left this reaction lies. And by doing this, we will eventually be able to find out how soluble it is. So if we go back, we know about Kc. So this is our equilibrium constant for concentration. So we have our concentration of our products on the top and our reactants on the bottom. However, unlike when using Kc, with this solubility equilibria, when we add more solid, so we add more reactant, this will not move our equilibrium further to the right. We will not form more products, we will not dissolve more, because no matter how much solid we add, if the solution is saturated, no more of it can dissolve. And because of this, we cannot use Kc as our equilibrium constant. We now use Ksp, and this is when we take out the concentration of our solid because it will not affect the equilibrium position, because no matter how much more of it we add, it will not move our equilibrium further to the right, because the solution can only dissolve so much. So now we're going to be looking further into Ksp. So what is this equilibrium constant? So this is called the solubility product, and it represents the conditions for equilibrium between a sparingly soluble solid and its saturated solution, and we'll look into what this means. So first, we said sparingly soluble solids were solids with a low solubility, and a saturated solution means that no more solid can be dissolved in it. So this Ksp, this solubility product, represents the conditions between these two states. And it's important to note that the value of Ksp is a constant at a certain temperature. So it is a constant that cannot change unless we change the temperature or the reaction. So now we're going to look further into it. So we can use solubility equilibria and our solubility product, our Ksp constant, to predict whether a precipitate will form from a solution. And in turn, this will be able to tell us what Ksp actually is and what information it actually gives us about the reaction and the solution. So if we see here, if the concentration of our calcium ions times the concentration of our carbonate ions in our solution is less than our fixed constant for Ksp, then the ions will stay in the solution. They will stay dissolved. So then, if our calcium ion concentration times our carbonate ion concentration is greater than our fixed value for Ksp, then some of our calcium carbonate will precipitate out. So a good proportion of it will stay in solution. However, the excess above our Ksp value will precipitate out into calcium carbonate. And so, if our calcium ion concentration times our carbonate ion concentration equals our fixed constant for Ksp, then the solution is said to be saturated. So we cannot add, if we add any more, then some will precipitate out. But at this moment, everything is dissolved. And if we add any more, it will not be able to dissolve. We cannot dissolve any more solid in this solution. So yes, this can tell us whether a precipitate will form. So we can predict whether a precipitate will form when we add our solid to a solution. However, what does this tell us about our Ksp and what it actually is? Ksp is the maximum value that the products of the ion concentrations can take before the solution is saturated and the precipitate forms. So Ksp is the maximum value that these concentrations, the product of these concentrations, can take before the solution becomes saturated and then a precipitate forms after that. And so because Ksp is this fixed value at a certain temperature, this allows us to find this maximum value, find this value where we'll have a saturated solution, and any product greater than this fixed value, a precipitate will form. So, if we go back to the beginning when we were talking about insoluble compounds and how no solid is actually insoluble, we can now explain that. Solids that we say are insoluble just have very small Ksp values. So this means that only a very tiny concentration of ions can dissolve before it precipitates out. So our maximum value that our product of ion concentrations can take, our Ksp, is very small. So when we add more than that tiny concentration, a precipitate will form. And it's also important to note again that Ksp does change with temperature. So Ksp is a fixed constant dependent on the temperature that the reaction is at.